The top of the hour on my clock, so we are going to get started. I want to thank everybody for joining me today, where we're going to be talking about resilient and cost-effective stormwater channels and using the GeoWeb Channel Protection System. So I am your host, Sam Justice, and I've been with Presto Geosystems for nearly 10 years now, after coming from the consulting world. I do have licenses as a professional engineer with degrees in civil and geotechnical engineering, and work with ASTM and ISO in the geosynthetics industry. I am one of the engineers here at Presto Geosystems, and we manufacture erosion control, stormwater management, and porous pavement products, all of which are made in the upper Midwest of the United States. Through an extensive national and international distribution network, we offer both technical and site support, as well as a free project evaluation service from our in-house engineering team, including myself. I do have a little bit of a cough today, so I hope you can bear with me and it isn't too disruptive. So, a little bit about what we're doing today. We are going to start with a good look at the GeoWeb system, what it is, how versatile it can be, learn how it can work in some different types of situations, including pipe outfall areas, high flow situations, and take a look at some of the university accredited research that was performed using the GeoWeb system so that you know we're not just making our numbers up. We do have some really good backing for what we're doing here. So Presto Geosystems collaborated with the U.S. Army Corps of Engineers to develop the geocell technology in the late 1970s, and we've remained at the forefront of innovation ever since. We offer more than just a product. We do partner with our customers from the initial concept phase all the way through construction to ensure project success. Our worldwide distribution network is highly experienced, not only in the geocell technology, but also other geosynthetics. And I firmly believe that we have one of the most knowledgeable distribution networks available. Our project assistance continues even after the product leaves our facility. We do operate in three main product areas. The first being our GeoWeb geocells, and those can be used for things like load support, slope and channel protection, and constructing green retaining walls. And then we also have a line of porous pavements, both a vegetated and a stone surface solution, and also lightweight reusable construction mats. Today, we are going to be focusing on the GeoWeb system, specifically for channel and flow applications. So I want to talk a little bit about GeoWeb geocells and how they function, how they're going to work for what we're trying to do here. So the GeoWeb system has two main characteristics, and those include the cell diameter and the cell size. The cells come in three diameters, basically a small, medium, and large. And then the cell wall heights are available in 5 different depths: 3, 4, 6, 8, and 12 inches. The actual cell size and cell height that you choose are going to depend on your specific project details and your site conditions. Presto offers a free evaluation service, which includes your written summary, calculations, cross-sections, specifications, and other supporting documentation, regardless of your project size. This evaluation will help determine the appropriate cell size and depth for your project. And to ensure your project success, we really strongly recommend against using things like standard tables or graphs. Sometimes you might have seen those out in the world, and they're a decent representation, I suppose, but they're just not very specific. And because each project is unique, especially when we start talking about having flow velocities over the system, it's really important to make sure you get one that is going to work for your site and your conditions and not just sort of hope for the best. Something else that I want to point out about a geocell is going to be the ultrasonically welded seam. And this is basically all of the connecting points of a geocell wall, and it's going to be crucial to the functionality of a geocell, how it's going to actually hold itself together. The stronger the seam strength, the better the geocell's performance is going to be. GeoWeb panels are made from 100% virgin high-density polyethylene, HDPE resin, providing the strongest wall strength while maintaining semi-rigid ductile properties. If a cell wall is too stiff, if it's not ductile enough, if it can't move and flex, it can overstress those seams and potentially cause seam rupture, which is a project failure, something we're all hoping to avoid. So I mentioned two characteristics. The second one is actually not the panel itself, but what you put into it, the infill material. There are four main types of infill that can be used with the GeoWeb system. And what you choose is going to be based on the project type and the required protection you are looking for. So your infill types are going to include coarse sands or granular material, topsoil, crushed aggregates, and concrete. This will often allow for the use of recycled or on-site materials, so you can potentially reduce or even eliminate the need to import fill to your site. And we can work with you and review on-site gradations to determine the most cost-effective infill material, and we'll include that in that project evaluation service that we offer. All of the infill types that can be used for the channel protection system. When used in channels, concrete is best when there's very, very high flow rates, which we're going to see in a little bit. Otherwise, aesthetics is probably going to be the driving factor, whether you choose between topsoil, concrete, or aggregate. So GWeb, as I mentioned, is manufactured with that proprietary blend of high quality virgin HDPE resin, and it has proven its durability over the last 40 plus years. GeoWeb does not contain any fillers such as calcium carbonates, recycled materials, polymer alloys, anything like that. The GeoWeb system is designed to last over 100 years, with lab testing showing it can withstand up to 149 years before any carbon black degradation, even with 24-hour sun exposure. So obviously you're not seeing the sun for 24 hours a day, and we haven't quite gotten to 149 years yet, so we're working on that, but we really do stand by our data, ensuring that you can confidently build with materials that you can trust. We are sure that the materials that we offer you are going to do what we say they will. And the GeoWeb system and all of our accessories are 100% made in the USA under strict quality assurance and environmental control processes. And they comply with all the requirements in the Build America, Buy America, and the Infrastructure Investments and Jobs Act. So if you are looking for maybe any federal dollars for your project, if you know that you have a certain amount of material that needs to be made in the USA, things like that, all of our products and all of our accessories meet those standards. And one of the reasons that Presto Geosystems can offer the world's most complete multi-component cellular confinement system, GeoWeb system, is that we have backed our innovations with accredited research and testing, and have done so since the creation of the GeoCell technology in the late 1970s. And we work with industry-leading GeoCell researchers from the US and around the world. And these are just a couple that we've worked with recently. We've done much, much more. We are constantly researching and innovating and making sure that what we're doing is going to be the best in class, best that we can offer you so that you know what you're putting in your project is going to be the right solution. All right. I mentioned a couple times components or accessories, multi-component system, all of that good stuff. So here are some of those accessories that I mentioned that allow for that, strong, fast, completely integrated system. The first one is going to be the Atra key, and it is a crucial component for a fully integrated system. Atra keys connect GeoWeb panels into a single system that covers your entire project area and significantly speeds up your installation time. Made from that durable HDE plastic, they will last the lifetime of the project. Atra keys ensure that the panel remains securely connected and that the GeoWeb system is not going to fail under anticipated loads. Their specific engineering values guarantee that the system has durability over time, avoiding the corrosion that you would see with metal staples, the failure of underperforming zip tie systems, all of that stuff that you might see on competitor GeoCell offerings. We also want to look at anchorage for what you're doing with the GeoWeb system. If the GeoWeb panels are laid flat, anchorage is not really necessary. The weight of the infill materials is going to hold everything in place. However, as your slope angle increases, you have to overcome friction, all of that stuff, and you want to make sure that it's not all just going to slough to the toe of your slope. So anchorage is necessary. For shallow slopes, and think, a 2 horizontal to 1 vertical around 26 degrees or shallower, you can use stake anchorage. We do have two options for that. One using your standard steel rebar, and the other one using a stake made of HDPE. So again, that same durable plastic material that the GeoWeb panels themselves are made of. And so that's what's shown in the photo here. We call it our Atra Speed Stake. It's really helpful in certain environmental conditions. Maybe if you're in a saline environment, you're along a coastline, if you know you have corrosive soil for any reason, something like that, using the HDPE stake is a great way to make sure that you are not having the corrosion that you might see with steel stakes. And stakes can be driven either by hand or by power drill, like you see this fellow here doing, for easy installation. Now you sometimes are going to have steeper slopes. They're steeper than a 2 horizontal to 1 vertical slope. You're going to have some other options, but you also might be putting your GeoWeb system over a geomembrane liner, something that you don't want to puncture. Or maybe you are in a sensitive environment where you just don't want to damage the slope face at all, something like that. All totally valid reasons. And so our second anchorage option is actually to use tendons. Tendons are a way of basically only anchoring the GeoWeb system at the crest of the slope, all the way at the top. You're not doing anything on the slope face itself. So, especially if you're, say, over a liner that you can't puncture, this is a great way to protect that liner, not have any puncture marks, anything like that. We do offer our Atra tendon clips, which are very advantageous when anchoring the tendons. So those tendons are securely fastened to the tendon clip, which you see in the left-hand photo there. And then the tendon clips are attached to the GeoWeb panels themselves. So there's no chance for the tendons to slip. It also allows for top of slope assembly, basically limiting the amount of time you have to spend actually on the slope face. So you're a little bit safer, times are a little bit faster, just makes it easier overall for that installation to go through. So there are two ways of building up the GeoWeb system on slopes and channels, things, this type of geometry. The first is what we call a single layer system, where the GeoWeb panels are laid directly on the channel bottom, on the side slopes, or maybe just the side slopes themselves. And then they're filled in with your desired infill material. So this is good for areas where the slopes are less than 45 degrees. So a 1-to-1, 100% slope or shallower. As long as there's room for the footprint of the actual channel itself, this is probably the most efficient way to protect against erosion. But sometimes your space is limited, or maybe your project area is already butting up against existing structures such as houses or roadways. In that case, your side slopes need to be much closer to vertical. In that case, the GeoWeb panels can be stacked on top of each other to create a retaining wall on one or both sides of the channel. GeoWeb retaining walls can withstand the same velocities and shear stresses that we're going to talk about, and they're still flexible enough to handle curves or changes in grade. So this is a great way to create sort of a deep channel with a minimized footprint. And so this is something that you can sort of mix and match. Like I said, you can put a retaining wall on one side, both sides. You can cover the side slopes and not the channel bottom. You can just do the channel bottom one side. There's lots of different options to really, meet what your site needs. There's not, it is something that is flexible to you and not just sort of, hey, this is the product, make it work for your site. The product actually fits and molds into what you need specifically. All right, so we got that basic overview of all of that out of the way. So I want to dig a little bit more into the capabilities and the functions of each of the infill types. So we're going to talk about each of the different main categories of infill. We're going to start with a vegetation infill. And I mentioned a couple times, but one of the best things about the GeoWeb system is how much trust that we have in the actual system working. That's because we have the experience and research to back up what we're saying. One of our biggest tests was with Colorado State University in Fort Collins, Colorado, under the direction of Dr. Chris Thornton. CSU is considered basically one of the top hydraulic research facilities in the world. It's got a pretty unique location underneath the Horsetooth Reservoir and has a couple hundred feet of static head. So it can achieve extremely high velocities and shear stresses in their research flumes, something that you necessarily won't see in a lot of places because they just don't have the power behind it. So it's a really great testing facility. Dr. Thornton is very widely respected. We're very happy that we were able to spend some time with him. So vegetated infill testing was performed with essentially two objectives in mind. The first was the ability to withstand those high velocities and high shear stresses. So the main components of what you think about when you have water flow over an area. And then that second objective was we wanted to compare the performance of a topsoil filled geoweb system against riprap or other conventional solutions. And so this testing that we did consisted of filling in the geoweb panels with that topsoil, and we put a surface protection. So we put in this case, a turf reinforcement mat on top to allow for that vegetation growth. It's pretty typical cross section that you might see. And then we were able to run those tests in a couple of their different flumes at a couple different slope angles and velocities and mix and match those conditions to figure out. We got some pretty impressive results. Held up really well, even against turbulent flows. So thinking around corners, going around rough terrain, that sort of thing. A lot of people tend to think that a vegetated channel can't actually handle significant water flow, which is true when it's an unreinforced channel, if it's just, natural topsoil and vegetation growing. But when properly confined in a GeoWeb panel, along with that surface protection, velocities of close to 30 feet per second and shear stresses of 16 PSF can be achieved. And so here you can actually see one of those tests going through. Doesn't look like much because there's so much water flowing over top of the GeoWeb panels. You don't actually even see the GeoWeb panel and vegetation under there. Something to keep in mind, there are lots of different types of grasses, and choosing what grows in your area, in your climate, is going to be the most important thing. But there are some hardier varieties of grass that may work better if you know you're going to achieve some of these higher velocities, that sort of thing. So I urge you to reach out to, your landscape architects, people who understand different types of grasses. I'll admit that's not something I'm super familiar with, but definitely you can talk to us about it or talk to somebody who knows what's going to grow in your area. So this is a pretty typical application of using the GeoWeb system, in this case alongside a highway, and it was compared to a conventional riprap system. So the riprap tends to look unfinished, in my opinion, especially after any sort of storm event where there might be some stones that got carried away, maybe trash has flown into here. You got weeds that are growing up through it. Tends to just kind of look messy and unfinished. And then you have the GeoWeb system here on the left-hand side, nice green grass growth. You know everything's in there and contained. You don't have to worry about it getting washed away, anything like that. It's going to look like this before and after your storm event. This was a case study that we did. So the GeoWeb system also works great along embankments that are going to see flow from the top to the bottom of the slope rather than sort of along a channel bottom. And so in the case, this was an embankment on the dry side of a pond that would see hopefully infrequent overtopping, but it was made of unstable soils because it was at an active gold mine in northern Canada. Had some variable slope lengths, had some variable face angles, so it wasn't, just a nice perfect embankment. It was sort of rough looking. So in this case, it was up near Toronto, and it is definitely a cold weather environment. And so the GeoWeb system stands up well to snow, frost heave, and ice. In this case, a access road was also going to be built above the embankment, sort of where you see that excavator sitting right now. And so the slope had to become stable enough to support the expected road traffic. And when used as an embankment, the GeoWeb system protects the slope from that water runoff and overtopping with no loss of vegetation along that slope face. Here you can also see some other space constraints that might be common on other sites that you might be seeing along your projects. So you have access roads so that on both the top and bottom. In this case, the embankment couldn't be regraded to something shallower, so it had to be this still pretty steep slope face. And a nice feature of the GeoWeb system is actually shown in the sort of inset after photo there, and is where a guardrail was installed both along the crest, so at the top of the slope, and then that fence along the toe of the slope. And so there's no limit to this sort of infrastructure being installed near or even on the GeoWeb panels. So it's really helpful in those sort of tight space constraints like this one. This slope here was alongside a road in Ohio, which was a pretty common problem that's solved with the GeoWeb system. Erosion and washout of the soil slopes onto your road surfaces is a problem in many locations. So in this case, you cover that slope with the GeoWeb system, fill it in with topsoil, and allow for that vegetation to start growing. And now you don't have the concern of having to constantly come in and replace the soil after each storm event. And here they chose to hydroseed on top of that soil to help promote that vegetation growth, get it going a little bit faster. You can also use things like erosion control blankets, coconut matting, that sort of thing. There was a project down in Florida. Here, the GeoWeb system was working along a shoreline of a hurricane stormwater channel. So they were placing the panels along the shoreline to help protect erosion due to that water movement and wave action. And so it was this diversion channel was collecting hurricane water, so it would fill up very fast and it would be very turbulent water as all of that water moved in with those hurricanes. So it needed to be able to withstand that turbulent water and then the rise and drawdown of water as the water come in, filled the diversion channel, and then eventually dissipated. And then obviously there was infrastructure on all sides of this channel. So they wanted to make sure that that got kept in place without any damage or future damage. So the GeoWeb panels here were placed both above and below the normal water line for this channel. And so the panels need to go below that water line to ensure that they don't get lifted up due to that wave action or due to the rise of water in the channel. And this makes sure that you're protecting that entire shoreline all the way down to your channel bed. The area does not have to be dewatered to do this type of installation. This can be a wet installation. The GeoWeb panels can basically be thrown into the water and then staked onto that slope face, make sure everything is held in place, and then you still dump your infill material in same as you normally would. And then once everything is actually in those GeoWeb panels, it's not going to get washed away even when underwater continuously. And then here you see that final surface after that vegetation has been established. In this case, they did choose some water-loving vegetation, but also were able to do a little bit of a mix and match. I keep saying that phrase, where they put stone underneath the main water line. So everywhere that was going to constantly be underwater, they filled it in with stone because grass doesn't like living underwater, and then had grass above it so that it looked nice and blended in with the surroundings. But even now, as the water rises in this channel and rises above the stone and gets to the vegetated section of the GeoWeb erosion protection system, it all is going to stay in place and it's not going to go anywhere. And one last thing that I kind of want to mention about vegetated infill is that you can put it over those geomembrane liners I've mentioned, but the GeoWeb panels themselves are deep enough to hold a sufficient amount of topsoil to still grow nice, healthy vegetation, even when it's over, a liner, so it's not going to penetrate into the native soil in any way. So here you can see that bright yellow liner underneath. Here the GeoWeb panels were just on the side slopes. They didn't feel the need to protect the bottom of this particular channel, but it all grows in very nicely. So you can see they went with some coconut matting to try and cover the system while that vegetation grows. But large vegetation in here, you got the grasses and everything growing. Everything still looks very clean and natural, and you have enough soil contained within the GeoWeb panels for good vegetation growth, even when it can't reach the natural subgrade. And now you can have all this water flow through this diversion channel. It's not going to go through because there's that liner. The liner is protected because you have the topsoil on top of it. All sorts of good things working together here. And in terms of maintenance, like vegetation maintenance, If the grasses start growing or if you have larger flowering vegetation, keep it with your standard lawn maintenance plans. You can ride a lawnmower, either sort of like a walk behind or a ride on lawnmower can go right over the top of these panels, and just let it grow like natural grass would. Don't make it more complicated than it has to be, you know? So very easy, very low maintenance. And honestly, you're not going to know that the GWeb panels are under here once that vegetation's in place. So one more project that I want to sort of mention here. This one was out in Sacramento, California. This was a concrete lined ditch and it had a culvert as well. And they were directing a really concentrated flow of stormwater runoff into the natural bank of this creek. So it was not only causing some pretty severe erosion in places along the creek, it was exposing the roots of some mature oak trees. And the erosion had caused those banks to erode and move to the point where they were becoming dangerously close to the homeowner's property and they were starting to worry about undermining. So this project was designed to have the construction start by unfortunately removing the oak trees with exposed roots that couldn't be saved, but then trying to save the rest of them, packing them back in with soil. And they actually chose to use the retaining wall option on that side to give as much space as possible to try and keep those trees. So they were able to stack the GWeb panels vertically on top of one another to create that retaining wall. And then they decided to just do the single layer system on the other side because they didn't need the vertical wall on that side. And they left the concrete and stone base of the channel there so that that would be sort of a natural creek bed for it to go on. And then let the vegetation come in. And you can see the left-hand photo is about a year after installation, vegetation starting to come in, but you still see the panels themselves. And then the couple years after that, you can see full vegetation going in. Trees are doing well, water's flowing, everything is all copacetic. So this is a great way to have still allowed the uh, runoff through this system, not reducing the amount of runoff in any way. But now you don't have to worry about, encroaching on the homeowner's property. Those trees are not going to have their roots exposed, so they have a better chance of living a long time. All good things that we're doing here. All right, so that was vegetated infill. Second one we're going to go to is aggregate infill, so stone infill. Again, we did testing at Colorado State University. And the main objective here was to determine how much the GWeb system can aid in reducing the stone size from your standard riprap stone down to a regular crushed aggregate stone. So we looked at how well the stones would stay in place during the tests to determine the rock size that would prevent washout. Because frankly, the system doesn't work if a stone can get picked up by the flow and then just wash downstream. It's got to be able to stay confined within the cells of the GWeb panel. All right. So the results here were pretty impressive as well. And so we were able to get up to 18 feet per second for a max velocity and a max shear stress of 16 feet per second. People who have a good head for numbers might remember the vegetated system could handle up to a 30 foot per second velocity. So pretty significant difference between topsoil and stone. But the difference here that I kind of want you to think about is a whole lawn of grass, all the roots interconnected, all those blades of grass held into the soil versus a single rock. So you can see why those are sort of different parameters that you're working with. Because with the stone or the aggregate infill, we wanted to make sure the stones themselves weren't getting picked up and washed away. We didn't want to empty out the cells because we were using stone that was too small, that sort of thing. So just something to keep in mind. And we're more than happy to talk about these in more detail if you're interested. I'm not going to get into a great amount of detail today because the idea that the Dr. Thornton put together was to create a design tool based on a regression analysis to compare the reduction in concrete in crushed aggregate confined within the GWeb panels to your conventional riprap stones. So the tool is based on all of that testing data, and it allows us to predict the rock loss and the rock size based on the specific hydraulic conditions of your site. And essentially what that comes down to is that we can recommend the appropriate cell depth and rock size for an individual project so that you can be confident that the stone placed in the system is not going to get washed away. So just something to keep in mind. You can sort of uh, not see too much here, but it does tell you that we're using, in this case, a D50 with 2 inches, so a 2-inch sized crushed aggregate compared to either a 10.3 inch riprap stone or a 16.7 inch riprap stone compared to standard riprap sizing options. So a reduction between 5 and 8 times of that stone size. So really significant, definitely going to save you on material costs, that sort of thing. And again, if you are interested in this research, I urge you, we are more than happy to share our results and all of the testing methodology that was used. So definitely just reach out. All right, some case studies. Minnesota DOT used the GeoWeb system to help stabilize the surface around bridge abutments and along railroad tracks. And the flexible nature of the GeoWeb panels means that it can easily contour to that slope face and around obstacles such as piles and bridge abutments. And so with that system in place, water erosion is prevented around those abutments, reducing your maintenance costs. And again, this project was a mixture of topsoil and aggregate infill. So the aggregate they used below the bridges where the vegetation would have difficulty establishing. You see it all the time as you're driving down highways, that sort of thing. Under bridges is either stone or concrete, and then the rest of the slope is nice green grass. In this case, they filled in the GeoWeb with stone under the bridges and then filled in the GeoWeb with topsoil and vegetation when it could get sunlight. Another project, this was for the Gila River Indian Reservation just south of Phoenix in Arizona. A heavy runoff from intense storms was leading to erosion and flooding around some adjacent subdivisions to this area. Several existing embankments and channel sections had failed under some recent 100-year storm events. Repair time was critical to reduce flooding and preventing runoff that could damage those residential areas. So the channel area was cleared of any sort of existing vegetation, scrub brush, that sort of thing. And then the sand subgrade was graded and compacted. To prevent that infill loss, they actually chose to use a non-woven geotextile underneath the GeoWeb panels. This helps keep the stone in the panels and prevents them from migrating down into the sand subgrade over time. So it acts as this nice separation layer and keeps everything where it's supposed to be. And so this was a wide, shallow channel. It had 3 horizontal to 1 vertical side slopes, so really quite shallow, you can see here. But it was actually approaching 100 feet wide in some locations. So really wide, very shallow. And so they were able to use the stake anchorage option to hold everything in place. And one of the other nice flexible things about the GeoWeb system is the ability to change the depth of the panel mid-project. So in this case, they had an 8-inch panel seen on the left side of the photo going down to a 4-inch panel seen on the right side of the photo. And that was because they had higher flows on the left side, on the upstream side of the channel, that were slowing down and getting reduced enough that the flow was able to be contained by the 4-inch panel. So this basically saved them on material costs, less GeoWeb panel, less infill material in the GeoWeb panel, easier to install. So you don't have to be stuck with the extra thick section the whole way through just because you have 1 or 2 areas of high flow or turbulent flow. They also had some outfall pipes coming into this area. That was where those turbulent areas were that had that thicker section of panel. But you can see the GeoWeb panels fit up nicely around those outfall pipes, excuse me, so that you don't have any potential areas of washout or erosion directly underneath the outfall where you have that turbulent flow, potentially very high flow during storm events, that sort of thing. So they were able to basically cut the GeoWeb panels to fit around these types of obstacles and then flow them into the channel and meet up with everything else. And so it's a pretty easy installation once they got into the swing of things. This crew was installing about 2,000 square feet of GWeb sections per hour, and that's with a 4-man crew plus an operator to fill in the stone. And so you can see some of that work happening here. Oh, excuse me, there's that cough. So the infill here was actually waste rock from a nearby quarry. So not great quality, not always known exactly what the gradation is. But that's one of the great things about the GeoWeb system is that you don't need high quality engineered stone. You can use the lower quality or the salvage stone because it's still going to work and be confined within the GeoWeb panels. The GeoWeb panels are carrying a lot of the load here, so you don't need the greatest stone that's ever existed. And also, one of the great things here was that you can actually drive on top of this when it's filled in with stone like this. So they're driving right on top of the GWeb panels filled in with stone. So it can act as its own access road. Drive on top and then fill out the stone in front of you. So keep filling in the panels, but driving on them as soon as you've already filled them in. So really advantageous in terms of installation sequencing, speeding up installation time. In this case, having a quarry nearby meant they didn't have to haul in material from very far away. So lots of little benefits that all add up to something that really worked out well for this type of location. And then here's what that looks like under typical flow conditions. They had a couple drop structures that were designed throughout the channel to help reduce the velocity before it reached the end of the channel where it went into an unprotected sort of natural state of the channel. So the GWeb system was no longer covering the bottom, but the velocity was low enough that there wasn't concern about it just tearing up and causing erosion to the natural channel. And with the aggregate protection system, there is little to no maintenance required. Since the aggregate's confined, you don't have to come back and replace it. You don't have to worry about it getting washed away during your storm events, anything like that. And then here the channel is large enough to accommodate storms without overtopping, so you don't have to worry about it falling over the sides or anything like that. Here was another project. This was at the Billings Logan International Airport in Montana, and it was built on top of sandstone rock with little to no topsoil. So even when vegetation was growing on this site, high velocity runoff areas caused erosion issues that needed to be addressed. So the GWeb system was chosen and it was filled with stone infill designed to protect this channel from erosion for up to 100-year storm events. The open graded aggregate allowed for that stormwater to infiltrate during low flow times into the groundwater system. And then 2 detention ponds were also built to help control the stormwater runoff that flows from the channel. And so the GeoWeb system was actually installed over a geosynthetic clay liner to help protect the banks of that pond. And so that helps with just a little bit of extra erosion resistance. This airport was sloped at 2%, so a very, very shallow grade for a large stormwater pipe system. And then that slope and those 48-inch pipes did produce some pretty high velocity storm events. And the challenge was lining those open channels and those high flow channels with a pervious material that would not create ponding, but still provide erosion control. And so the GeoWeb system with a clear stone fill was a good fit for that desired infiltration over time. All right, and now our last infill type, I'm trying to go a little quicker here now. It is concrete, and this is going to give you that impervious cover to your channels. And again, testing was done at Colorado State University. We ran a couple different tests. The concrete filled GeoWeb doesn't require any additional reinforcement. So you're not putting rebar in there. You're not doing like a fiber reinforced concrete, anything like that. You're just pouring your concrete directly into the GeoWeb panels. And they actually maxed out the flume at CSU at 36 feet per second. Water was actually overtopping and coming out the top of the flume, which they said had never happened before and has not happened since. We are the only product to ever actually overtop and max out their flume. So the testing shows 36 feet per second, but we are very confident and have experience in significantly higher flow velocities over concrete filled geoweb, which is not super surprising. I mean, concrete itself is intended for those very high flow velocities, but filling the geoweb panels with that concrete is a great way to reduce the thickness of your concrete. You can go as low as a 3-inch section all the way through. And it's a great way to incorporate other geosynthetics such as wicking layers, geomembrane liners, that sort of thing, without having additional infrastructure. And so this type of system, concrete filled geoweb, is comparable to things like articulated concrete blocks, ACBs, excuse me, TRMs, ECBs, that sort of thing. So it is still in that sort of category, in that vein of geosynthetic reinforcement, but it does give you all of the benefits of concrete. So concrete filled geoweb is best when you know there's going to be that very fast water flow. This was a channel project at a train intermodal yard down in Texas. So the geoweb system actually was a value engineered option that came in to replace a 6-inch reinforced concrete channel plus, excuse me, to replace a 12-inch rebar reinforced channel with a 6-inch deep geoweb panel. And so the geoweb actually also went up on the side slopes and was only 4 inches deep. So again, they had that transition from a thick panel where the water flow was going to be to a slightly thinner panel in areas that weren't going to see the high water flow. So this was a great way where the geoweb system was actually able to save the owner a couple $1 million. So $1 million, not going to argue with that. But more importantly, it sped up construction and allowed the yard to be in service significantly quicker than originally planned. So the side slopes of this channel used 3-inch deep geoweb panels anchored with stakes because the slopes were relatively short and flat. And then the bottom of that channel used the 6-inch deep geoweb panels so it could support clean out equipment without fear of damage. So the slightly thicker concrete was able to support those heavy vehicle loads and withstand the water flows. Here you can see it all going in. One of the neat things about this type of system with the geoweb filling in with concrete is that the panels act as their own formwork. So there's no need to build additional forms, which can be tricky on slopes and increase your construction time, materials, all that stuff. So the concrete is poured directly into the geoweb panels from the top to the bottom, and then the cells hold that concrete in place and prevent it from slumping or creating areas of uneven thickness. And so one of the great benefits of the geoweb system is that you have a consistent concrete thickness across your entire project because the concrete is screed flush with the top of the geoweb panels. So you know it is always exactly 3 inches, 4 inches, 6 inches deep. But this is still a concrete structure. You do have to account for pore pressure buildup. You can drill weep holes through the set concrete. You can install weep piping through the panels before you pour the concrete. Whatever you need to do, just don't forget pore pressure. That will be the death of all engineers at some point. So geoweb filled with concrete is great, still subject to water pressure. All right. And then here's what that looks like from the sky. I thought that was a pretty cool thing. It was over 1 million square feet of geoweb. So you have the channel down the middle where the water flow is going to be, and then up and over the sides for erosion protection in case of overtopping, anything like that. And it got that rail yard back in service significantly faster than planned. And now it has a safe way to contain all of the water that would come through. One last thing that we're going to cover today are actually some sort of unique conditions or special cases. And those are going to be outfall areas and very, very high flow situations, somewhere that you might need a little bit extra. So outfall areas can be challenging because they typically have some pretty high velocities and shear stresses, typically higher than the channel as a whole. And the water in these areas are usually turbulent as they come out of the pipes, rather than a laminar flow that you would hope to see in the rest of your channel. Using the geoweb system can help mitigate some of these concerns, especially if you use concrete, because that turbulent flow and those high velocities are just not going to be an issue if you have that concrete filled geoweb. And the option to mix your infill types is really beneficial here. So do concrete around your pipe outfalls and then transition to stone or topsoil once you've gotten away from those turbulent areas to get that sort of more aesthetic appeal. And the geode system can be used in conjunction with those larger riprap stones when there is that potential for high flows. This was a culvert outfall in Milwaukee, Wisconsin. And so a strong surface protection was put over the panels. In this case, they used a core fabric. And then they just sort of blended in with the existing riprap that had been there. But now the GWeb panels extended further up the sides of those slopes in case of very high flow events. And you can sort of imagine this was intended for more short duration flows rather than, continuous flow. But now you have that protection and you don't have to worry about it. If you got to that 100-year storm event or a 200-year storm event, something that you maybe weren't anticipating, you still have that protection. And then the other special condition is going to be those very high flow situations where it needs to be, that flow needs to be reduced by the end of the channel. And that's where you're going to include energy dissipation. And so dissipators can be added to any concrete filled GWeb panel. They can't be added to stone or topsoil because they need to be anchored into the channel a little bit better. And concrete is going to be the way to go with that. Plus, you're in a high flow situation. You're going to need concrete anyway. And so they can be as low tech as just throwing some boulders on top and grouting them into place to something a little more uniform, this nice sort of patterned dissipator that you have here. And you can see how nicely that looks. And so they can be placed on those very steep slopes, same as the GWeb panels. So basically, if a GWeb panel can be placed there, dissipators can be incorporated into the panels. Utilizing a tiered system on the slope like this can limit the height and angle of the channel while still containing and directing that water down slope. So something to consider if you are, in this case, this was tens of meters tall, so very tall slope. They were able to sort of terrace it a little bit to break up the water flow. But in this case, the dissipators were able to be put in with that concrete. So they're incorporated into the GWeb system. So they're not a separate piece. So they're not going to sort of like break off and fall away. It's all a single concrete monolith. And then, so the number of dissipators, the size of them, the spacing of them, all of those things are really going to be dependent on your anticipated flow and your channel conditions. There is no one right way to include energy dissipation, but it is something that myself and the engineering team here can help with on a case-by-case basis. So if you know that this is something that you're going to need for your site, definitely reach out to us. Happy for the challenge, that sort of thing. And again, you can do that mix and match within the GWeb panels. You can see they have the concrete with the dissipators in the center of the channel, transitioning to topsoil and vegetation on the sides. And then I just think this is a cool picture. Look at the water coming through here. It was actually coming down out of the mountains and falling into a stilling basin. So you can imagine they really needed that water to be a lot slower than it is coming out of the slope here. So this was a pretty cool project. And not a lot of projects like these. This is a very unique condition, but it's one of those sort of things that the GWeb system can handle. And we want you just to know that it can handle these types of things because you might not think of it right away. But that's my show. So in summary, the GWeb channel protection system has great flexibility of its design, a variety of infill materials to meet your project needs. You can go with topsoil, aggregate, concrete. You can have that protection against surface erosion all the way from, shallow intermittent flows up to high velocity flows, constant water flows, that sort of thing. And we are backed by over 40 years of experience and extensive research and testing to validate what we're offering. And I mentioned it, if you are interested in that testing that we did at Colorado State University, definitely reach out and we can give you your copy of this research. We also have another webinar, I believe in 2 weeks on July 21st, to talk about this in more detail, I urge you to sign up and attend that webinar. There's going to be a lot of great information. It's going to be a lot more technical than I covered today. So definitely is going to get into sort of the nitty gritty about it. So definitely try and tune in for that one. Project evaluation service, mentioned that a number of times as well. Go to our website, you'll see something that up top where it says free project evaluation. Fill in with as much detail as you have. And then we are going to give you a written summary, calculations, CAD details, specifications, supporting documents, all of those good things. And so we're going to get you this for your specific project condition so you know it's going to work for you. We're not basing this off a graph or off a table and saying, good luck. We know that this is going to work for you and we have the data to back it up. And so, like I said, you are going to get all of those documents. Usually takes 2 to 3 business days. But reach out to us if it's an urgent situation. Sometimes we have time to accommodate. But we're going to work with you to get the best design for your project. And we do deliver quality and over 40 years of expertise, guaranteeing each shipment meets or exceeds our specifications so you can deliver certainty and build with materials you can trust. No disclaimers, no fine print. Almost made it. Housekeeping here at the end, PDH certificates. So if you attended live today, you will get an email by the end of the day from GoToWebinar with your PDH certificate. And then you will get another email at the end of the week from Presto Geosystems with links to the webinar dashboard. And so this webinar has been recorded and it's going to get put up on that dashboard. The slides are going to be up on the dashboard. Like, you'll be able to download everything from there, rewatch the webinar as much as you like. All the good resource information is up there. And then you can also see our library of other webinars that we've done. You can earn some PDH credits watching some on-demand webinars there. Lots of good resources. So 2 emails, one from GoToWebinar by the end of the day, if watching live, and one from Presto Geosystems by the end of the week with the recording of this webinar. As always, check your spam folders, but if you really don't see anything, if you need some help, reach out to us. We're able to help make sure everybody gets what they need. All right, here's my contact info. Please reach out to me. I love hearing about your projects. I love hearing about what's going on out there. I am good for any sort of technical assistance, whether it's 10,000 foot, we just started looking at this, could maybe GeoWeb work for this project, all the way down to, hey, we've got to get this put out for bid next week. We need all the details put together. Give me everything you got and all your technical resources, and I can put that package together for you as well. So definitely reach out. We're more than happy to discuss any of your projects. GeoWeb is not the solution for every project, but it is going to be a solution for a lot of them. And we do have the best distribution network out there, and we can make sure that you have the appropriate product. Hopefully GeoWeb, but maybe not, maybe someone else, but it's going to meet your project challenges. So I have a couple questions in the webinar here that I would be happy to answer. So the Q&A is going to be recorded. So if you have a chance, stick around and I'd be happy to discuss that. Otherwise, check back at the end of the week when you get on the webinar dashboard, and the Q&A will be on there as well. So a couple people are asking about the webinar I mentioned in 2 weeks. You might have already seen some emails from Presto Geosystems saying sign up. There's going to be more emails coming out next week, giving you a chance to register for that webinar. You'll do it the exact same way you registered for this one. So look for those from Presto Geosystems, sign up for it. If you aren't seeing that email for some reason, reach out to me. I'm more than happy to forward you that registration and get you signed up, because you definitely should attend. It's going to be a really good technical resource for you. Some other questions. Can you use the product to incorporate steps down a slope into your bank? So yes, so you can incorporate stairs or, either like a built up stairs or incorporate steps into the slope face. A couple different options there, but sort of the overarching answer is yes, you can include other infrastructure within the GeoWeb system to achieve your needs, whether it's a drive lane to get clean out vehicles into your channel, steps for pedestrian access down into a channel, up over a channel, etc., that sort of thing. Fencing, guard posts, signage, all of those sorts of things can be incorporated into the GeoWeb system. Pretty easy to do. Happy to discuss details on a more specific basis, but basically the answer is yes there. Oh, excuse me. So can you basically can you use this to stabilize the bank of the slope? So that's an important thing to keep in mind is if you're seeing erosion on a bank slope, you need to determine, is it just surface erosion because water is flowing on it or near it, or is there an actual global stability concern with the slope that's causing large mass movement, circular failure, something like that? Because which one of those you're seeing is going to depend on which solution you need to fix it, right? And so the GeoWeb system can handle both scenarios. If it's just superficial erosion, you just need to cover it up and prevent water from washing away erodible soil. Pretty easy. You just lay the GeoWeb directly on that slope face. If you are seeing more of a global stability concern, big circular failure, something like that, you're going to want to start getting into like a retaining wall solution, something with internal reinforcement, something that gets deeper into the slope and try and get past those slip failure planes. So the answer is yes, we can definitely help with both options, but it's really important to figure out which type of destabilization you're seeing on site. So hope that helps. Couple questions about the thickness of the GeoWeb system. So it depends on what your infill material is. The GeoWeb panels go from 3 inches to 12 inches. So that's sort of your bounding factors, I guess I would say. With concrete, you're typically going to see pretty thin sections, usually 3 inches or 4 inches, unless you have extenuating circumstances. With topsoil, you're typically going to see maybe 4 or 6 inches, depending on how much soil you need to grow your vegetation. Stone, you might see a little bit thicker, 6 inches or 8 inches, that sort of thing. But it is a very project dependent thing to determine what your panel thickness, your material thickness is going to be. It is going to depend on your site conditions, on your hydraulic flow conditions. Are you going to be driving any vehicles on top of it, pedestrian loads, that sort of thing. So there's no one right answer, and that's where I'm trying to reiterate, don't stick to like tables because they don't see the whole picture, right? They're just sort of guessing and hoping that you fall within the normal parameters of what a project is. And, that's probably fine for some projects. If you've got just simple, normal, nothing unusual, yeah, you can probably sort of just average yourself in the middle and say it's good. But if you've got sort of any extremes, you really want to make sure you're addressing those in your design considerations. Let's see. I see I've got time for one more question. So the panels themselves. So are they? How are the panels going to hold up, and how are they maintained? So the panels themselves, like I said, are HDPE, and they have a UV stabilizer in them. It's called carbon black. But basically, they're not going to break down or degrade in sort of environmental conditions, and that's sun exposure, water exposure, potential, high pH soil exposure, something like that. So any of your field conditions are not going to have an issue with this chemically inert plastic. And it's not going to break down or crack or release microplastics, anything like that, because of those conditions. And we have that testing up to 149 years, showing that they are going to be durable up to that. And then in terms of maintenance, you can just run your lawnmower over it to mow the grass. Stone, you don't really need to do a lot of maintenance. maybe pull some weeds if you're in a weedy area, but you don't really have to do a lot of maintenance. You're not replacing stone in there at all. Concrete, you're not replacing. You can, if you need to for any reason, if like you need to get underneath the panels for some reason, not necessarily something you see a lot in channel projects, but you see it in some other types of applications. You can like cut out a section of the G-Web, pull that out, do your underground work, and then you would slot in a new section of G-Web, use that Atra key to connect it back to the rest of the existing project, fill it back in with your infill material, and then you still have your nice continuous coverage. So you do have the ability to do maintenance on the system if necessary. That's very unusual to need to do something like that, but it is possible. So that's good to know. But I have reached the end of my hour. I won't take up any more of your time. Thank you all for attending. If I did not get to your question, definitely reach out to me. And I'm more than happy to discuss it over email, over phone, anything like that. Share your projects with me. I love to see them. And I hope to see everybody in the next webinar. Thanks.